Let's talk about geometric sequences. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. So some geometric sequences are powers of r to the n, with r being a fixed number like 2 to the n, 3 to the n, and so forth. So for what values of r is the sequence r to the n convergent? Well, let's consider some different values and see. What if r is greater than 1? So 2 to the n or 3 to the n. And we can see as n increases in integer values that we're going to be multiplying this number greater than 1 together, and it's going to become larger and larger. So this is going to be divergent. What if r equaled 1? We'd have 1 to the n, and 1 to the n, 1 times 1 times 1, whatever many times, is always 1. So the terms of our sequence are always 1. This is a convergent sequence then because it is a constant, and the limit of this equals that constant, so it converges to 1. What about if the r is something between 0 and 1? So you can think of it as a fraction like a half, or a decimal like 0.2. If we multiply a half times a half, we get a fourth, times another half, we get an eighth. And we can see as we keep multiplying by this fraction less than 1 that we're getting smaller and smaller. And in fact then, if that r is between 0 and 1, it's going to decrease and it's going to head towards a limit of 0, and it is convergent. What if r is between -1 and 0? So like -1/2 or -0.2. Well, as we multiply a negative together, every time we are on an even-powered integer, it's going to be positive, and every time we're on an odd-powered integer, it's going to be negative. So it's going to alternate signs, but its magnitude is going to get smaller and smaller. And so we can see it alternates on either side of 0, but it is approaching 0 and is convergent. What if the r equaled -1? Well, for each odd integer we put in, we're going to get -1. For each even integer we put in, -1 to the even power, is going to be +1. So this is going to jump between -1, 1, -1, 1. So this is divergent because it is alternating there. It is not converging to a number. What if the r is less than -1? So -2 or -3, and we can see that in that case, again, we're going to have this alternating signs, but the absolute value or magnitude of this is going to become larger and larger, and so this is divergent. Okay, let's put all of this together then. So when we had an r greater than 1, it diverged. When we had r equaling 1, it converged to 1. When we had r between 0 and 1, it converged to 0. If we had r between -1 and 0, it also converged to 0. And if we had r equaling -1, it diverged because it alternated between -1 and 1. And if we had r less than -1, it also diverged. So we can kind of summarize all of this, and this is going to be useful to us as we look for convergent and divergent sequences. So basically we found that at -1 it diverged because it alternated there, and at 1 it converged, so we're going to color that in. And then if we had things between -1 and 1, it converged. So if we were outside of that on either side, it diverged. So the sequence r to the n is convergent if the r is between -1 and 1, can be inclusive of the 1 but not the -1, and it is divergent for all other values. And then the limit as n goes to infinity is 0 if we're between -1 and 1, and it's 1 if it equaled 1. This is a geometric sequence.